Welcome to the Explainer. Today, we're diving into a breakthrough that could totally change how you interact with your phone. Seriously. We are talking about a new framework that might finally let the AI on your device learn directly from, well, from you. I mean, just think about it. An AI assistant that doesn't just take generic commands, but actually gets your unique way of talking, understands your life's context, and starts to anticipate what you need. And, this is the big one, it does all of that while keeping your data completely private, right there on your device. That's always been the dream, right? But it's been just out of reach. Well, maybe until now. Okay, so here's how we're going to break this down. First, we need to understand the huge problem that researchers call the three walls. Then, we'll get into the super clever, kind of weird solution they came up with, thinking without gradients. After that, we'll unpack the PRGE framework that makes it all tick, look at the pretty impressive results, and then finally talk about what this really means for that little computer in your pocket. So for years, this idea of a truly personal AI on our phones has been, well, just an idea. And it's because it wasn't just one single problem. It was blocked by three fundamental barriers that, with the tech we had, seemed pretty much impossible to get past. Researchers have a great name for these, the three walls. First up, you've got the memory wall. See, traditional AI training needs to store a ton of data while it's learning, way more memory than your phone has. Then there's the compute wall. The processor in your phone, it's awesome for using an AI, but for the heavy lifting of training one, not so much. And finally, the infrastructure wall. The actual software that runs AI on your phone is built for a one-way street, inference, not the complex two-way process of learning. And just to really hammer home that memory problem, look at this number. To fine-tune even a kind of smallish AI model, a 7 billion parameter one, you'd need over 45 gigabytes of RAM. That's more than most high-end gaming laptops have, little on a smartphone. So yeah, the old way of doing things, a complete non-starter on mobile. So, okay, if you can't just smash through those walls with brute force, what do? You got to get creative. You have to find a way around them. And that meant coming up with a totally new way to think about AI training, one that basically throws out the most resource-hungry part of the whole deal. You see, the normal way we train an AI is with a method called backpropagation. The best way to think about it is like giving the AI a very precise, very detailed map to find the best answer. It works great, but calculating and creating that map is what eats up all the memory and processing power. This new way, called zeroth order optimization, it's different. It's gradient-free. It has to find its way without a map. So without that perfect map, what does it do? Well, ZO optimization is a lot like trying to find the lowest point in a pitch-black, hilly room. You can't see anything, so you can't just walk to the bottom. Instead, you just take a few little steps in a bunch of random directions. You feel which way went downhill, even just a little, and then you take a bigger step that way. It's a really clever method of just feeling around for the right answer, which, as you can imagine, uses way fewer resources. Okay, so this feeling around in the dark idea is super clever, right? But the next challenge is making it actually practical. How do you make it fast enough and efficient enough to run on a phone? That is where this PRGE framework comes into the picture. The whole solution is basically a one-two punch of two really smart innovations. The first is PRGE itself, which stands for Parallelized Randomized Gradient Estimation. That's just a fancy way of saying it's a super fast method for testing all those random directions at the exact same time. The second piece is called LoRaFA, which is a technique that lets the AI learn by changing only a teeny tiny fraction of itself. You put those two together and the whole process becomes incredibly efficient. So here's the play-by-play. Instead of doing things one by one, the system creates what it calls a mega batch. It takes an input from you, makes a bunch of copies, and then nudges the AI model in lots of tiny random directions for each copy. Then, and this is the key, it processes all of those nudged versions at once to see which ones did the best job. It calculates the best direction from all that data and makes one tiny smart update to the model. The genius is that it's all done in one massive parallel step. And this is the real secret weapon. The framework actually bakes this entire update logic directly into the model's own structure. So what it's doing is basically tricking the phone's software, which, remember, is only built to run AI, into performing a full training step. The model becomes self-updating. It completely bypasses that infrastructure wall we talked about. It's brilliant. Okay, that all sounds incredible on paper, right? A self-updating AI on your phone. But the billion-dollar question is always the same. Does it actually work? Let's take a look at the results and see if this thing is really as smart and fast as it claims to be. So to put it to the test, the researchers took a model called Tiny Llama and trained it on a sentiment analysis task, basically deciding if a sentence is positive or negative. They put their new PRGE framework head-to-head with an older, similar method called Mizzo, and, well, the results speak for themselves. PRG didn't just work, it was actually more accurate. Because it tests a whole bunch of directions at once, it gets a more stable, reliable idea of the best way to update itself. That led to better performance, all while using the exact same amount of computing power for each learning step. And here's the kicker. It wasn't just more accurate, it was also a lot faster. Because of its parallel design, doing everything at once, the framework was almost twice as fast in real-world time compared to the old methods that did things one at a time. So you're getting better results in nearly half the time. That is a massive win. All right, so let's bring this all home. We have a system that's accurate, that's fast, and that actually works on a normal phone. So what does this breakthrough really mean for you and me? What it means is that we might finally get the best of all worlds. We get true personalization, where our AI assistants actually get to know us. We get ultimate privacy, because our sensitive data never has to be sent to a server in the cloud. And we get incredible efficiency, because it all happens on the phone you already have. And, the researchers who built this, they don't just see it as some clever programming trick. They see it as the foundation for something much bigger. This is the practical, proven groundwork for a whole new generation of apps that can adapt securely and intelligently to every single one of us. This kind of technology really does open up a whole new world. It's a shift from apps that are just pre-programmed to be smart to apps that can actually learn and evolve with you. And that leaves us with one final, pretty exciting question to think about. When your apps can learn, what are you going to teach them?